So continuing on with chemical reactions and quantities, and again, now that we've kind of done stoichiometry, it tends to be both reactions and quantities both at the same time. So before we get going into limiting reactants, we can think about limiting reactants in a number of different ways. To kind of simplify things, I think kind of going over a problem. If at the beginning of the first day of school, or at the beginning of a semester, I have to make handouts for my class. Each packet needs to have 2 syllabi and 1 year plan, with the syllabi being multiple sheets. If I printed off 180 syllabi and 180 year plan sheets, how many complete packets can I make? Will I have extra sheets? And if so, which ones are they? An example like this allows us to kind of see some things, and we can see that each packet, and in a way, we're putting things together. We're able to see and kind of put some of this together that, I need to make a packet for every student. Each packet needs to have 1 year plan and 2 syllabi. And what we've just basically done now is make essentially a stoichiometry problem or a chemical reaction or whatever you may be for that there. We wouldn't write ones, and so we would get rid of them. And so we would say that 2 syllabi plus 1 year plan gives me 1 packet. Well, if I have 180 syllabi, I would divide that by 2 to get it into, say, a common thing. And my 80 would be divided by 1 to get into that commonality. And then I would see that I would actually have more than enough syllabi, but limiting me in how many plans or how many packets I make is the number of year plans. In all reality, though, I would have a total of 2 syllabi per those 10 extra, which would make me actually have 20 extra sheets of syllabi. Now, you could have wrote it out like this, or maybe you wanted to write it out as saying S2 plus, that's not 2, that's an A. S2 plus Y to give us P. That would be that same premise, that same idea. It doesn't really matter for this example on which one you go with. That same logic can be applied to chemical reactions. And now we just need to deal with the number of particles, usually moles, because moles are a chemist's best friend. And when in doubt, convert to moles is usually what we can do. We cannot compare grams to grams. We can't compare grams of one item to grams of another item. And the reason for that is because the molar mass is going to change how that all pans out. The molar mass is going to change how much of that compound in moles, because we can compare moles to moles. We can convert moles of one thing to moles of another thing, and that's why we can do that. We can't convert grams of one thing to grams of another without going through that mole ratio that we've been talking about. And so therefore, we can't compare grams to grams directly. We have to go through the mole. Now we can compare the moles directly. Now how that's done, there's a number of different methods that we will kind of look at or discuss. Some of them I find to be more cumbersome and more difficult than I think they need to be. So I tend to go a route that I feel I've had a lot of students in the past have more success at than and less confusion. So the limiting reactant is the reactant that controls how much product's being formed. Something is limiting your production of what you want, whether that be bicycles or chemical reactions, whatever it may be. There's something limiting your production. In a lot of what we do, it's going to be the reactants. And so we're now going to have two reactants given to us. We have yet to deal with anything that has two givens. So far, everything we've had has been one given and one want. Well, now we're going to have two givens and two wants. So limiting reactant problems have two givens, and both of them are reactants. And there is always that one want still, but this is going to always be, with this, is usually going to be a product now. And so we're trying to find which one it is. If something is given to us in excess, meaning that it is more than that is there, that's usually what that excess reagent is. The limiting reactant or reagent is the thing that limits our production. And so how we look at this can be a little bit different. I've seen chemical examples where they do two full stoichiometry problems. Now that might not be for you. I've seen examples in reference material where they do reactants when they convert to both of the reactants and then determine which one has more of the other. I find that sometimes to be a little confusing, and so instead what I do is you convert both of them to moles and then convert one to moles of the other thing is the route that I do, and we'll go over some examples of that in a little bit. So an example of this in a simplistic manner is for a reaction like this, which is 1-to-1. If I happen to have 1 mole of silver nitrate and reacts with 2 moles of sodium chloride, well, because it's 1-to-1, those 2 moles of sodium chloride are more than enough than I need to react with that 1 mole of silver nitrate. Now that can make life a little bit interesting, but usually something in a reaction is going to actually limit your production. And so now it just becomes that part of a thing is, what is it that is limiting my ability to make as much as I want? It would be like the same if you went into the kitchen and you wanted to make a meal. Well, you are going to be limited on what or how much you make of a certain meal based on the materials or the items that you have in your home to make it. That's why we make shopping lists, because that's kind of what we end up doing here is we're making a product, a meal, so to speak, and something is going to limit your ability to do that. Or maybe not everybody will be fed, and therefore you're not going to have something limited, everybody getting what they want, is what kind of a limiting reactant looks like. And that's not a bad way to think about limiting reactants is, I'm making something. I'm making muffins. I'm making cookies. I'm making a meal. What is it that is going to limit the amount of that meal or that batch of muffins or that batch of cookies that I'm going to make?